All right, ladies and gentlemen. We're actually continuing activity 1 with activity 2. Chromate esters are unstable, unlike carboxylic esters, which are very, very, very stable. And this is what happens to them. If there's water around after you've made them, water, and that gives these 3 things. Now, let's do an example of I'm stuck 101. Like, what do I do if I'm stuck? Try to figure out what atoms moved. What do you call a reaction that makes water into hydronium? You're answering that question from 20 minutes ago, both of you. It's happened twice today already. What do you call it when H2O picks up a certain species and becomes hydronium? Acid base. Is water an acid or a base here? It's a base. What is the hydrogen that does not that does exist here, but does not exist here? This is stick figures 101. What hydrogen exists in this species and does not exist here, because you have to draw it on the carbonyl. It's the aldehyde, former alcohol carbon. Sorry, alcohol. If you don't draw it, you can't do this mechanism. I think you can finish this mechanism for me. Well, the students who are finally getting mechanisms can do this mechanism for me now. They've never seen it before. That's my goal, to get you to do mechanisms you haven't seen before, following patterns you have seen before. So what are you going to do? You need to write 2 little objects on the screen first. What are they? They're very small objects, about as small as they get. The lone pair, that's the object I was looking for. And it goes where? The hydrogen, the blue one, right? What are you going to do with the sigma between the C and H? You've done this earlier today. Pi between C and O. And this is a classic elimination. It looks like an elimination. And the leaving group's just weird. And the reason it leaves is chromium got reduced. This was Cr plus 6. This is Cr plus 5. It's called reduction, right? But look at the question before this. It doesn't have the word reduction in it, does it? What's the word in the question? Yeah, but you got to remember what class you're taking. Are you taking inorganic chemistry where we only talk about chromium? No. You're taking organic chemistry. Talk to me about what happened to your carbon. What's the oxidation state? Hey, finally, the semester's almost over. I'm going to put a question mark and a question mark. Oxidation states. Question mark goes to question mark. I need a number for the first question mark. I want to remind you there was an H there already as well, a black one. -2 and +1 for oxygen. So what's the overall? -1. Thank you very much. And when you're done, don't forget the H. There it is. You got a -1 for the H and 2 positive ones for the O. Yeah, what do you call that reaction? There's the answer to the question. Yes, answer. Quack. No, you didn't hear it. So the people watching this video just think the teacher lost his mind. But somebody's phone just went quack. Okay. Sorry. Yeah, it's goofy time of the semester. We've all lost our minds. Going from -1 to +1 is called what? Thank you. There's the answer to the question, right? Question mark became oxidized. Oxidation. Just highlight the answer. I'm getting more and more into non-verbal answers. I don't know why. There's some words. Okay. What's going on here? What is the fate of an aldehyde after it has undergone chromic acid oxidation number 1? This was oxidation number 1 right here. Oxidation number 1. Yeah, aldehydes, they do this first. What do you call this reaction? We're going to have every water reaction before the end of the day. We've done 2 so far. We did dehydration earlier. We did condensation earlier. Water reactions involve water as a reactant or a product. Now, when you remember condensation, you should remember its opposite with it. Don't do those opposites first. Do the other opposites first. What's the opposite of dehydration? The words give you the answer, by the way. Hydration. Chapter 6, you did that. Chapter 10, right here, you're doing that. You're adding water to a molecule. What's that called? Say it again. Hydration. So those are the 2 out of the 4 that are easy to remember. I'm putting it on the wrong arrow. So when I ask you about the 4 water reactions and you need the opposites, hydration, dehydration into your brain immediately. What was the big one that made 2 little guys become a big guy and lose water? 2 guys became a big guy and we lost water. It's called condensation or dehydration synthesis. What's the opposite of condensation? 2 guys, one is water, react and water breaks the other molecule apart. Hydrolysis. Somebody tried to sneak that answer in earlier. They were 20 minutes ahead. Okay. So there's your 4. There's a whole section of the textbook, the start of the chromic acid discussions, all about the 4 reactions of water. There's a whole page spent on it. Okay, we're doing a hydration. Chapter 6, you did it with a different kind of pi bond. What was your first step in chapter 6? I want to make this one look like chapter 6. Remember chapter 6? The 2 first reactions you studied, HX, which was HBr and HCl, or water and sulfuric acid. Right here, water and sulfuric acid. In all of those reactions, what's the first step? Do what to the pi bond? Protonate it. Now you're going to protonate it. Do you want to put the H on the O and make a C plus, or put the H on the carbon and make an O plus? O doesn't even like hearing that second question. Okay, you've seen O plus many times, but only when there's not an octet violation. O will not do a plus and an octet violation, not like carbon. So you're protonating the O. Here's the arrows, just like chapter 6, and nobody's protonating with water anymore, right? Nobody's pretending water's a stronger acid than sulfuric acid. We've grown past that. And you have a lovely oxonium here. Oh, I got rid of the pi. Where's my plus? And it's a really stable. Why is it really stable? Don't talk to me about hyperconjugation. I'm gonna give you a mean look. Hyperconjugation says it's really unstable because it's primary. Yeah. Normally, haram. Not now, because something more important than hyperconjugation is available when oxygen has a, or even 2 lone pairs. It's called resonance. It doesn't matter. How are you going to get the new O on there? This one you know already. Add the water lone pair, right? Right to the carbocation all the way to the C. That doesn't change. And you've got something that looks a heck of a lot like that thing up there. I don't know. I'm not finished. I'm almost finished. I forgot my blue H down here. Hey, they look almost the same, don't they? And of course, he remembers sulfate ion conveniently because he now needs it. What's it going to do? Regenerate the catalyst while generating the hydrate of the aldehyde. What did he just say? An aldehyde has just become an aldehyde hydrate during a hydration reaction. That all makes sense, I hope. Aldehyde hydrate is a new functional group you've never seen before. That's why why was I puzzled? Because it's new. The important thing to know is an aldehyde hydrate has OH groups just like alcohol. What do alcohols like doing with ic acids? You want me to read this 2 sentences from the previous activity? What do alcohols like doing with ic acid? Any ic acid can react with an alcohol in a condensation reaction to make an ester. Guess what we're doing next? Making an ester. I know it's not an alcohol, but it sure looks like one, right? It's got OHs. It became an ester. Chromate ester number 2. Chromate ester number 2. What was ester number 1? Ester number 1. We already dealt with it. We made it on the previous page. We reacted it on this page. Okay, we got to get there because the last part's easy. Shall we go back and look at the steps? It's that important. We're going to see it on 6 of our 6 next tests. For the people that weren't here, what is he talking about? That doesn't make sense. We only got a final left. What did he just say? What about chromate ester formation did I say at the start of class? Nobody remembers. You're going to have it on every exam in this class from now on, which is only the final, and every exam in Chem 242. You will now see that on 2 videos. I really hope you think it's important. Okay. So first step was take the lone pair on the ic acid, the double bonded O, and protonate it. Got it? That's what we're doing next. So which one of these is the ic acid? Is it the hydrate or is it the chromic acid? I think I answered my own question. We got chromic acid reacting with a strong acid. We'll go with green arrows. You got your Cr, purple, double OH plus OH, OH, double O. Can you remind me the next step from the previous page? I want to make sure these guys are separate from each other. There you go. So after you protonated, what did you do with the protonated version of where are you? You're here. There he is. What did it get attacked by? Where did this start? Lone pair on alcohol. Lone pair on hydrate. That's the best we got. Looks like I'm going to use this O here. It doesn't matter. There's 2 equal O's. Got to come in over that yellow. And which pi do you break? The one that resonates with the plus or the one that does not? Yeah, that resonates with the plus. That's the reason we made the plus, so we can resonate with it. Okay, green, go green. Ew. I didn't say that. Okay, that O is now also bonded to chromium, purple. Cr double O on top, OH to the right, OH to the left, and OH down. Oxonium. Yeah, you made this first molecule. You also made hydrogen sulfate ion. What are you going to do with hydrogen sulfate ion? Oh, take which H? the oxonium H, the strong acid H. It better be strong. Sulfate ion is a weak base. Sorry. All right, we got to set up for our dehydration. You say he's definitely out of room. I am not out of room because it's my last intermediate that I have to draw for the whole page. Green, purple, chromium, double O, single O number 1, single O number 2. Pick one of those O's to have a sigma bond to H. And tell me how that becomes that. I'll save. And a bounce back. This is the hydrate, and I'm dehydrating. Remember that? To make the ester, dehydration's at the end. So it's going to lose H here and one of these OHs. Over here, we're reminded that when you had the hydrate, and I didn't write hydrate, I'll write it now. Hydrate. And this last step is dehydration. And this is a hydrate. And the last step's called dehydration. Don't need those words, they're just to help you learn, okay? And you need both the base and the acid. Here's the acid, HOSO3H. Here's the base, O minus SO3H. Don't forget that minus. What's the minus grab? Proton. Which of those protons looks the nicest to grab? In reality, you can grab any of the protons from OH. But I drew one with its bond showing for this reason. I want to grab that one. What happens to the sigma between O and H? Becomes pi. And this thing leaves. But it can't leave as hydroxide. So it leaves as it protonates. So yeah, and it looks like tautomerization and elimination. A lot of similarities there. And the last one, I don't need to draw more molecules. All the work needs to be done on this molecule. And it's at the top of the screen. It's here. How did I decide this H had to be grabbed? Well, I looked at the product. There's only one H on that carbon. There was two H's on this carbon in the stick figure. Well, that's just proof. Are there any H's on this carbon? Where am I? Here. Are there any H's? This arrow went. No, we're going from here to here. Are there any H's on this carbon? No. Are there any H's on the same carbon over here? That's the carbon. It's got an H. Guys, it's the one attached to the O attached to chromium every time. It's on the carbon attached to the O of the chromate ester. What grabs that H? It's real close. Water. What happens to the sigma between the C and the H? It's like a broken record. It becomes a pi. What happens to the chromium? It leaves. Done. That's the oxidation step. I'll just write it down there. Oxidation. That little step is called oxidation. Doesn't work with normal esters, just chromate esters. And I do, before we move on from this, we're finished this middle area here, I do want to remind you from the very beginning, you started activity 1 like this, and you reacted it with H2CrO4, H2SO4, and water, and you ended up with these 3 species right here. H3O+, plus HCrO3 plus what functional group here? What functional group is that? Right there. Somebody said it. They were shy. Carboxylic acid. So what is your result when you take a primary alcohol and react it with chromic acid? What functional group do you end up with? Carboxylic acid. Okay, this is activity 1 and 2 together. Okay. And to finish this activity, the question is, and you don't know the answer yet, unless some of you have read ahead, which is cool. How can I stop at the aldehyde? Remember, the aldehyde is where we began here because we were told aldehyde, this is not the end. What is the fate of an aldehyde after it has undergone chromic acid oxidation? It's not done. It's an intermediate if you made it and then reacted it, right? Well, I want it to be the final product here. Hey, if you can prevent this step, that's one way to stop this reaction. And what's the best way to prevent a hydration reaction from happening? It's easier to get dehydrated in Arizona than Michigan. There's less water. Get rid of the water. So we're going to need chemicals that don't have water. Sadly, there's a story I haven't told yet that I'm going to put over here. You can't buy chromic acid. It is too unstable. So when you need it, you make it when you need it. I don't think I needed that comma. Question is how? You must know both ways. Can't be more straightforward than that. And the nice thing is, there's 3 ingredients both ways. 2 of them are the same both times. Water, H2SO4. You can add CrO3, which is chromium 6. Wow. Chromium 6 oxide. And you get CrO3, huh? Hey, the blue stuff's new, isn't it? Hey, what do you call that reaction? It's got 3 new atoms that when you add up their formula, you get what molecule? Water, which you just added to that molecule. What do you call that? So synthesis makes a bigger molecule, not just by adding water. No. Hydration. Yeah. Okay, you can also start with water, sulfuric acid, and a more popular form of chromium. I'm even choosing a color that might help some people remember. Why do you think I chose that color? You guys have dealt with dichromate. I know, so long ago you forgot. It was an orange solution. There you go. Yeah. CrO3, accidental color perfection here. CrO3 is a black powder. I did not do that one on purpose, though. Okay. So there's some stuff you got to know. Maybe it's, in a box. It'll help. Nice, neat box. Yeah, it's magic. Okay. Next up. You didn't have to write that down, but if you did, it's great. So this is just new stuff. And on a test, if I need that box filled, you're allowed to do this. But I'd like to remind you, PCC stands for pyridinium chlorochromate. Ladies and gentlemen, draw it. How do you draw pyridine? You drew that, well, you had it on the last test. What molecule do you draw and put an atom in the place of carbon? You draw benzene. Here's your idea to remember it. Draw benzene. Erase one of the corners. And put a nitrogen there. He wants the lone pair because he's in his brain, he's always thinking about mechanisms, and that's what you do with pyridine. Nice job. But it's not pyridine. The name says pyridinium. What do you do what you just said? Well, I'll do what I said. No lone pair. It reacted and it picked up a proton. So there's your cation. What's your anion? It's listed right above it. Draw chromate. Draw chromate. That's chromate from your 141 days, right? Not very well. It is? Yeah, it is. I promise. But replace one of the O's with chlorine. Chlorochromate. And there's no water here. So it only does one oxidation. So if you need an aldehyde from a primary alcohol, remember, it only works with primary alcohols. You better use PCC to get an aldehyde. Because if you use chromic acid, what do you get instead of a aldehyde? If you use chromic acid, what do you get? There it is. Carboxylic acid from a primary alcohol. Good page, good answers, good job.